Assalamualaikum. Hi, my name is Sofia Amira from Group 1. Today, me and my teammates will be presenting about the uses of organic compounds in commercial industrial applications and living systems of alkene.
First things first, what is alkene? An alkene is a type of organic compound that consists only of carbon and hydrogen atoms connected by single bonds, with general formula of CnH2n plus 2 where n is 1, 2, 3, 4 and more. Alkenes are named by identifying the longest continuous carbon chain and using a prefix to indicate the number of carbon, followed by a suffix n. Example, CH3, CH2, CH3 is propane. CH3, CH2, CH2, CH3 is butane. Alkenes have a basic structure of carbon and hydrogen atom linked by single bonds. These bonds are formed by the overlap of sp3 hybridized orbitals of carbon atoms with each other and with the 1s orbitals of hydrogen atoms.
Explore the fascinating world of alkenes by examining their chemical and physical properties. Alkenes are unique organic compounds with distinct characteristics that makes them incredibly useful in our daily lives. Starting with their chemical properties, alkenes are remarkably unreactive due to their strong non-polar carbon-carbon and carbon-hydrogen single bonds. This stability means they don't easily break apart or react with other substances under normal conditions. When they do react, it's primarily through combustion and halogenation reaction, where they burn in the presence of oxygen or react with halogenation like chlorine or bromine. What makes alkenes so stable? They are non-polar molecules composed entirely of carbon and hydrogen atoms with no charged regions to attract other reactive substances. Moving to their physical properties, you'll notice that alkenes are generally colorless and odorless compounds. As we move up the alkane series from methane to larger molecules, their melting and boiling points increase with molecular weight. This happens because larger molecules have more surface area for intermolecular forces to act upon. One crucial property is that alkenes are insoluble in water. Since water is polar and alkenes are non-polar, they simply don't mix, following the chemistry principle that light dissolves light.
The applications of alkenes. Alkenes have two significant applications in both commercial, industrial, and living systems. In industrial settings, alkenes are primarily used as fuels such as gasoline, diesel, and natural gases. For example, heating and power generation. They are also served as essential raw materials in producing plastic, synthetic rubbers, and other organic compounds. On the other hand, within living systems, alkenes are not highly reactive and usually doesn't engage in complex biological processes. However, some alkenes may function as protective wax, pheromones, or structural components in more complex molecules.
Alkenes are simple organic compounds with vital roles in our daily lives. They serve as primary components in fuels, such as natural gas, methane, and ethane, used for heating and generating electricity. Beyond fuel, longer alkenes act as protective agents, forming a water repellent layer that prevents rust on metals. Additionally, alkenes are effective solvents like hexane, capable of dissolving gases, oils, and waxes, making them useful in cleaning processes like dry cleaning.
These three examples of using alkenes in living system. First is plant waxes, which is alkene are a major component of the waxy radicals that cover the surface of plants, leaf, and stem, providing a protective barrier against water loss and pathogen attack. Next is insect radicals. Alkenes have been found to play a role in nerve protection for a certain insects, preventing desiccations and providing structural support. Lastly is ant stinging. Some alkenes like formic acid, which is also found in ant venom, are hypothesized to be involved in the delivery or spread of formic acid through contact points and when ants sting. In conclusions, alkenes are the simplest type of hydrocarbon, consisting only carbon and hydrogen atom connected by a single bond. Due to their saturated nature and strong CC and CH bond, they are chemically stable and relatively less reactive under normal conditions. However, they can go under important reactions such as combustions, halogenations, cracking, isomerizations, and reforming under specific conditions. This reaction makes alkene valuable as fuels and as raw material in the petrochemical industry. Their chemical behavior reflects their key role in both natural processes and industrial application.